Thanks, Glenn. Let me share my screen. And since the one time at CamundaCon where I forgot the screen share, I will ask that question. Can you see my screen? Yeah? Cool.
Yes.
I personally always hated that question, and then I forgot it once in the CamundaCon keynote. So since then, I start to ask it again. Yeah, thanks, Glenn, for the introduction. Thanks also, Suresh, for setting this up, hosting this. I know it's a lot of work to get together the community, and I really appreciate that because I love to have these also regional events with a bit of more focus on also probably regional topics. For today, I want to talk about automating processes in modern architectures. I want to basically setting the scene wise, I don't want to talk about that very much, but what you can see nowadays basically everywhere is what's pretty well described by this, that all companies fear death by Amazon. So we have a setting with digitalization, digital transformation, that a lot of business models, a lot of companies are threatened basically by being overtaken by competition that might digitalize in a more efficient way. And that very often means I can provide totally new business models or run the existing business models in a much more efficient way. And that's kind of the scenery we are in actually. And part of that is also means that because everything gets digital, and actually most of the companies I work with don't have a lot of physical goods they send around. Most of the stuff they send around is information. And that means a vital part of the business is really software development around how to handle this information. And one good article about that, it's obviously biased. It's when Microsoft acquired GitHub 2 years ago. In the press release, they said something which totally speaks from my heart. Today, every company is becoming a software company and developers are the center of digital transformation. So choices these developers make will increasingly determine value creation and growth. And that's one core primitive, which is also very much in our values of providing what we call developer-friendly process automation. I come to that, back to that a bit later, but I think that it explains a lot around, first of all, how we build a platform, how we deliver it, but also about the problems people are having. And if you look at this environment of digital transformation, one thing that gets very clear, and that was quite different from my perspective 2 or 3 or at least 4 years back, is that we really get awareness for that the only constant is change. And I love that quote. There was 2019 before COVID, so you could go to lunch together with the CIO from an insurance company in Germany. And he said, okay, we also don't know what will happen tomorrow, but we know that there will be something. And if that shows up, if that change shows up, we need to be able to move very, very quickly. And that's my job, to get the organization into a state where it's able to move quickly when it understands what needs to be done. And this is about agility and not only about agile software development, what we basically did like 10 years back as a big movement, but really about business agility, like being able to adjust the business model, being able to adjust the business process very, very easily. And the interesting part is, if you contrast that to what we see as a reality in most companies nowadays, that's a huge contrast. And I mean, that's kind of the obvious thing, like paper, and especially COVID basically showed that very well, that paper is not very easy. With paper, it's not very easy to adjust business processes, right? But there are other examples which are as non-agile as paper. And my favorite example is the following. And I saw this in more or less the same way at different companies, at different use cases, in different scenarios. But I love using this because it's very easy to understand. So let's assume your task is to build a very, I'm not sure if that's simple, but you're tasked to build a payment service, like a microservice, for example. And let's say that payment microservice should provide a REST API for clients to retrieve payments, like, hey, order fulfillment wants to retrieve payment for the order. that's your task. And you should be able to charge credit cards as part of the payment. So you're probably not doing the credit card charging mechanism yourself. So you will leverage another service, probably in the internet, some SaaS service like Stripe, in order to do credit card handling. And let's assume that's also like has a REST API. So that sounds pretty simple, right? You want to have one service providing a REST API, and that needs to consume another service having also a REST API. But the interesting part is it's not that simple. So problems already start here, especially if you go to the internet, but very often also already if you're in your local network. And I mean, nowadays with the cloud around the corner, there's not much local network left most of the time. So the service is in the internet, and that means you have to at least think about the possibility that this is not available. It might be the service, it might be the network towards the service, whatever it is. But it's at least a possibility that this service is not available the moment you try to call it, right? And that has implications. I mean, the naive way of handling that would be the payment service saying, hey, I can't retrieve payment for you out of fulfillment. The credit card handling is not available. But that's not a good solution to the problem. I mean, the responsibility of the payment microservice is to retrieve payment. And if that takes a little bit, it should still do it. And very often that's the better architecture to have the responsibility in the payment service. And that normally leads to, okay, then I need to wait for the credit card service to become available. How do I do that? I probably add a table to the mix, because then I can store all the requests for payment in that table. Then I probably add a scheduling component in order to look at that table and collect open payments, and so on and so forth. So I start to build certain things in order to get that requirement going. Okay, but normally, I mean, that's already a lot of stuff you have to build, but normally it doesn't stop there. So let's assume you have some kind of malicious payment, some weird data there in the table. Then you probably can't call the credit card handling anymore. Probably that stops everything from working. I've seen that a couple of times. So you need to add some scripting in order to look into all the open payments, if the data is correct, to fix the data. If that happens, somebody might approach you, hey, what open payments do we have in that table? How do we go about that? And so on and so forth. So you add a lot of things around that very easy requirement of calling the credit card handling like reliably, and probably also, like, if it's not available, waiting for that. And this is a very simple example, but you can see that you build a lot of things around. And if you contrast that again with business agility, you're far from it. So if you want to change certain things around how you handle payments, it's super hard actually to do. And very often it's not even possible for people which were not involved in kind of the first product, because you have to build so many things around that. And if you contrast that to using a workflow engine as an example, and that's okay, that's probably my bias, but I try to do everything with a workflow engine all the time. So if you use a workflow engine for that, you could express a process model, probably a very simple one, like just charging the credit card. And then you get all these requirements like handling state, scheduling for retrying, for example, building. Okay, that's what the workflow engine can do. Suresh as well as Nile are doing a bit of an introduction how that really looks in code. So I haven't, normally I do a live demo as well, because I love live demos. It explains things very well, but I saved the time here because we see that later on. But on kind of a conceptual level, it works like this. You have probably your code for providing the REST API, and there you can use the workflow engine API to kick off process instances. And that normally means like, okay, there's one instance started. That instance moves along the process model, probably now waiting in the charge credit card task for the credit card service to be available, for example. That means this process instance alongside with the current state where it's currently waiting is entered into the persistence of the workflow engine, which in case of Camunda VPM, it's a relational database. And you can imagine it really like this, where you say, okay, it's currently waiting in that activity. And These service tasks like charging the credit card, there again, you attach code where you say what should be done in that case. When the workflow engine runs through, you simply call the REST client. So what you can see, and that's a bit the developer friendliness I referred to in the beginning, what you can see is that it's 90% normal, in this case, Java and Spring code. It might be different programming languages as well. Suresh, I think, probably goes more into the .NET stack. In this case, it's Java, but it's normal programming. That's kind of the message. It's not too specific to Camunda or to workflow engines. Okay. And then, I mean, if you're interested, yeah, okay, that's clear, I think, in this context, but I normally love to make my bias very transparent. I contributed to a couple of open source workflow engines in the past. I'm very, very much thinking about every problem through the lens of a workflow engine of process automation. That's important to know. Yeah, good hint. If you want to reach out to me, either now in the Q&A or if you get back to any question later on, feel free to reach out to me on Twitter, email, whatever works for you, LinkedIn. I'm in most of the stuff anyway. Okay, we already talked about Camunda. Quick question, and I like to do these little polls in between to see if you're still with me. What's your, like the audience, what's your current status with Camunda? Just also to judge, am I, what do you say, preaching to the choir? Okay. We're getting, that was interesting. The people that are in production with Camunda were fastest in answering the question. I'm not sure if that gives us any insight. I just recognized it. Okay, we have a head-on-head race. We have a really a head-on-head race between I'm new and I'm in production, developing. So we have a really quite commonly distributed audience. Okay, pretty cool. Awesome. Thank you so much. That's always interesting, and it always helps me a bit also to see if we're on the right level in a way. Great. Thank you. So for all the newbies, what I said early on, we will see more demos later on, and I've put the code on slide. I apologize for that. I hate code on slides. I love code in IDEs, but not on slide. But I just wanted to point you at this exact example I was talking about charging the credit card, retrying it in Spring Boot in a very easy way. It's also on GitHub. So there's the link. You will get the slides later on, so you can check it out yourself. You can run it yourself relatively easily. So just wanted to point that out. I'm not going into any detail. I want to fly a bit more on the conceptual level now. And from that perspective, good question might be, why am I telling you that REST calls? It's probably not what you do all days, right? I'm probably, you do it, but not as kind of the main problem why you look into Camunda or workflow engines. What I find interesting, now you have an idea of what the technology can do, and now you can think about what do I want to do with that? And I normally see the value of such a workflow engine on 2 dimensions. So the first is you get this, what I call long-running capabilities. You can wait for things like humans, asynchronous answers, the REST service to be available, whatever you want to wait for. That's long-running. And the second is you get visibility. You can see the process model. You can see analysis on top of that. You can see if something is stuck, where is it stuck? So I'm pretty sure we will see a couple of examples today in the various demos. So that's, from my perspective, the 2 main axes of value you get. And this REST example I just had, it leverages some of the long-running capabilities. So it might make sense for you, actually. It doesn't really leverage visibility in a very, very sophisticated way. So that's kind of, yeah, you can do that, but there are other things you could do. We have somebody unmuted, which is very loud here. Can we mute him? Hang on, I have to mute somebody. So better. What you can do as well, for example, I have to get back to the slides. You could also have more sophisticated integration patterns being supported, like waiting for 2 or 3 messages before you continue. There are a couple of these message aggregation patterns, for example, you could support. But the thing most people are probably thinking about when I say workflow engine, process automation might be around process orchestration, or in the context of microservices, it's microservices orchestration. Okay, I will talk about that in a second. And there are other use cases. I love that, business transactions, so the whole saga pattern. I'm not talking about that today, but if you Google it, there are a couple of sources around that as well. And one thing I like to mention here as well, some people also use it for what I call graphical programming. So no long-running capabilities needed at all, but I want to see it. And that's kind of the use case where I'm always a bit like, yeah, you can do that. Probably not sure if that's the best idea, because I mean, truth be told, of course, you have to learn a couple of things in order to use the workflow engine. You have to introduce a library. You might have a couple of problems. I think we lowered the barrier pretty good, but it's still there. So this is how I think about, like, what should I do with the workflow engine? And we started here because I wanted you to understand how a workflow engine ticks and what long running can mean. But then I want to jump to the microservices orchestration use case, because as you can see, this is kind of where you get much more value from the whole thing. And if you talk about microservices, I don't want to introduce microservices here. I think that's done often enough by now. But the whole idea is like, okay, instead of building a monolithic application which has a couple of business capabilities and functionality like embedded in one thing, I basically separate that into different services. The important thing about these services is that you want to gain autonomy. And autonomy means that you can do changes without basically affecting other microservices. That's the goal. And that, for example, means that you have a team caring about the microservice. So you're not, you don't need two teams in order to do a change in a microservice. So that means that microservice team also owns the data schema, for example. So I don't have to go to the database team in order to do something there. It means I have my own runtime environment, which nowadays might be a container. It might be Iron. It might be a virtual machine. I don't care actually, but I don't share an application server with 10 other teams where all they deploy their applications onto, and somebody else's application can break my own one. So that's the whole idea. So then I can do things in isolation. Okay. And I come back to that because that's important for a couple of primitives around process automation in microservices architectures. But again, a quick poll. It's kind of, let's see what we get today. So it's the answer to this question changed over the last years, pretty much. Let's see what people are doing. My guess, it's pretty much already around my guess. I mean, I can't guess the exact numbers, but I would say we're doing the first steps. I expect that to be the top level answer, but prove me wrong. Then this one is second and this is third, probably. But seems we're having a lot of broad-based microservices adapter. That's pretty cool. And that definitely changed over the last 2 or 3 years. Okay, thank you very much. I don't want to steal everybody's time too much, but I find that super interesting. It gives me a chance to see if you're still with me as well. If you're not doing microservices, or some people tell me they don't like that hype term microservices. You don't have to call it microservices. And from my perspective, what you do is you have different components, different functionality actually, and that functionality provides an API. And it might be very different things. It might be a microservice. It might be external services like SaaS or cloud services, which are there ready to use. It might be functions. If you're looking at serverless, for example, it might be serverless functions. It might be your existing standard software or legacy software that also should provide some parts or some functionality via API. If it doesn't, that's, for example, a use case for robotic process automation, RPA, in order to make functionality available as an API. And that's kind of the landscape we're getting at. There are a lot of good studies how much applications typical organizations now have, and that's increasing basically by the day. So we have more and more and more of these kind of components, and Now the interesting question gets like, okay, how can I get something out of that mess of things? How can I implement, for example, an end-to-end business process out of all these pieces? How can I puzzle it together to get something working? And that's the challenge. I find that the most, yeah, okay, probably the most interesting is the wrong word, but the most pressing challenge nowadays, because we make it easier with, for example, microservices and serverless to build the one component, but we make it harder to integrate all of these because we get so many of them. And now there are various ways to integrate these. One very famous approach at the moment is event-driven architecture. It's not a new concept. Event-driven architecture has been around for more than a decade, basically. There was this groundbreaking book, Event-Driven Architecture, 12, 13 years ago. I don't remember exactly. But over the last 3 or 4 years, it really took off. Also, like in parallel with the success of, for example, Apache Kafka. And that goes into the direction of what's called a reactive architecture. So the idea is the following. And I always like doing order fulfillment examples because my observation is that people can relate to that very easily. They can understand it relatively easily. So if you think of an order fulfillment and like a mail order company, they might have a couple of microservices, one for checking out stuff, one for retrieving payment, collecting the money, one for inventory management and shipping stuff out of the door, right? Now, event-driven could mean that you have certain so-called domain events that are emitted from these components, probably to some central event bus. That's kind of the normal architecture, where you say, okay, probably checkout publishes an event like, hey, there was an order placed, or another service says, okay, the payment was received, or hey, the goods were shipped. Right? So these are events that something has happened somewhere in some service in your architecture. And now what this allows to do is it allows to build certain functionality that reacts to this event. So for example, you could build one notification service that sends out customer notifications, like emails to the customer, like whatever it is, like a text message or whatever you want to have. And that's great because now you have that in one place. You have all the logic to how do I send emails? Did the customer want these emails? Did they give their consent? Whatever that is, how what's the text of the email and so on and so forth, right? You put all of that in one place and that makes it much easier to maintain. And you don't have to think about when to send emails within the payment service, for example. So that's a good idea. That's a good use of events and event-driven architecture. Now the problem, as always, is if you have that new hammer, every problem is a nail, right? Now this was applied over the last years to a lot of architectures in a lot of scenarios, and there's still 2 problems you have to solve. So it's not like now everything is fine, but there are 2 problems you have to solve. First, you have to implement long-running behavior. I'm not talking about this because I already introduced that. I just wanted to have it on the slide for completeness. But the second problem is now a lot of projects actually used this kind of event-driven architectures to implement business processes, like and that's a problem. I try to explain that now. So if you think about the order fulfillment process from beginning to end, like I want to have something till I have it in my hands, you could implement that by using events or event subscriptions. You could say some component says, hey, there was an order placed. So you could say that the payment microservice subscribes to that event, says, if there was something paid, I have to retrieve money. And then it probably emits another event, and the inventory service could say, okay, then, hey, if there was payment received, I have to collect goods from stock, and so on and so forth. So by having these different event subscriptions, you implement the business process. The problem I have with that is you don't see that anymore. So there's nowhere you can look at your architecture to understand how that business process is implemented. Right? Instead, you have two possibilities. You either look into all the code bases to understand event subscriptions and puzzle it together, or you basically observe runtime behavior to try to, kind of reason about what's the underlying business process behind what you can see. Okay, that's a huge problem actually, and it manifested in a couple of products. So by now there are a couple of different blog posts that also describe their experiences with that. So for example, Martin Fowler, which is kind of a credible source in that sense, he wrote already in 2017, by the way, but it's still not knowledge that's everywhere. The danger is that it's very easy to make nicely decoupled systems with event notification without realizing that you're losing sight of a larger scale flow and thus set yourself up for trouble in future. Okay, so that's kind of the problem. I love also this quote. This is from Phil Calzado. He did a talk at QCon New York in 2019. He worked at Meetup at that time, and they were using an event-driven architecture. And he described also the same problem, and he named it the pinball machine architecture. I made my own slide for that. So it's like you basically throw in like the first event and dong, 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 it moves through the system, and it's really hard to understand what just happened. Right? I mean, most often you have more than 3 or 4 services, so there's a lot of ping pong going on, and it very often leads to a situation where people say like, our system can't do that. How did that happen? That should not be possible in the system. And that's emergent behavior. It's hard to understand and it's hard to control. And you can also make simple examples where this really leads to problems as soon as you want to change something. Let's say the sequence of steps, the sequence of collecting the money and fetching the goods, right? Because you want to fetch it immediately because you want to check if it's on stock, for example, before you collect the money. Or there are a lot of reasons actually to adjust also the sequence of steps in a business process. I mean, in the very beginning, we talked about business agility and how this affects business processes and business models. So we no longer have processes that are stable for years. You very often have these kind of situations where you want to change things. And if you want to do that, you can think about it. Payment no longer should listen to order placed, but okay, now when there's good fetch, but good fetch needs to listen to order placed, but no longer to payment received. And shipment should no longer listen to goods fetch, but to payment received. So, right, I think I even messed it up. And I talked about that already a lot of times. So it's complicated, right? You have to change 3 subscriptions, the event subscriptions at the same time in a way. That's one of the big problems here. You can't just deploy the change isolated in one microservice. And that's a goal with microservices. You can't do that anymore because you have to coordinate the change, the deployment of it. You have a versioning problem and you have a distributed versioning problem across a couple of microservices. And that's really, really hard to handle. And that's very often forgotten when people think about these kind of event-driven architectures. I don't think that's a good idea. I don't think that's a good place to be. And this, I mean, if there are a lot of conference talks, for example, about event-driven systems, about choreography, and that's the term associated with event-driven systems. And normally the metaphor goes like, that's kind of like a dance, and it's a beautiful dance, and they have rules how to behave in a way. And then that means there can be another professional dancer added to the mix, and it will be beautiful. And it's not exactly what I see happening in real life. It's much more chaotic. It's sometimes really hard to manage, hard to understand what's going on, and hard to control. And that's something you should have in mind. I'm currently having a hypothesis around why this is happening relatively often, because it's very tempting. It looks easy in the beginning. And I had that discussion with a lot of companies by now, and very often in the beginning, they don't believe me. It's like, no, event-driven architectures are great. We have somebody who should be muted again. Yeah, cool. So for example, if you have the first service emitting events, that's fine. Then you can immediately build another service reacting to that event. So you don't even have to talk to the people here. Hey, that's awesome. That's so uncoupled or decoupled. That's so flexible. You can add the next service and so on and so forth. And that probably works if you only add stuff. But it breaks, it falls apart as soon as you want to change things, as soon as you need to understand how things work. So it looks easy in the beginning when you add things. And from my perspective, that's kind of adding technical depth over time. Right. So what has happened, I saw examples of customers where they were very well aware of the problem and said, okay, we want to start with an event-driven system 100%. We're a startup. We have to go to market as fast as possible. And if we collect technical debt, we don't care. If we are successful, we rebuild the system anyway in 1 or 2 years. Right. So that might be a good decision. But most projects seems not to be aware of that problem. And I find that very important. What's the alternative? The alternative is that, first of all, you extract the responsibility around, in this case, order fulfillment, like the sequence of things, like what should happen, into an own microservice. What comes along with that, and that's also very often forgotten, is you have responsibility in the organization for the capability of order fulfillment. And that's also a big puzzle for me all the time. If I think of companies like Zalando is a Camunda customer since ages, and they do order fulfillment. So every order with Zalando go over the Camunda platform. And I could never imagine that such a company says, okay, the order fulfillment, which is the heart of the company, it emerges out of some event ping pong. No, they want to have some kind of control over that, and they want to have somebody being responsible. They want to have somebody they can ask if orders are not delivered, if it's too slow, if there's certain weird situations happening. They want to have somebody being responsible. They don't want to like have a vacuum of responsibility, asking all the service teams, hey, what did you do? Why didn't that fit together? I mean, it makes a lot of sense to have that microservice of order fulfillment. And then this microservice might still react to certain events. That's totally fine. But it needs to be able to also control or coordinate others. So this microservice now decides, okay, there was an order placed. So the first thing we want to do is retrieve payment. And then we wait for the payment to be retrieved before we do next things like, for example, taking it from inventory. Right. Okay, and that's orchestration. That's coordination of others. And now a common misconception when I say microservices orchestration, people think of BPM and SOA like 10 years back, where we had architectures where such an orchestration was a centralized, very often a centralized software running somewhere. But this is not how I see orchestration. I see orchestration basically as I coordinate some action in another service. So this is nothing centralized. The orchestration logic lies within the order fulfillment microservice. Okay, and it might still react to events, which is choreography if I react to an event. So it's a mix normally. Most of the architectures is really a mix. Technology-wise, can everything. You can use Kafka to transport this commands to retrieve a payment. You can use messages. You can use REST. You can use whatever you want to do. It's not connected. That's another misconception a lot of people have. Like, hey, events, they are asynchronous. But commanding, coordinating, orchestrate, that's synchronous REST calls. I don't want to have that. It's not connected. And you could definitely code the orchestration logic by hand, like in Java or whatever code you have. That's possible. But because of the long running, what we said in the very beginning, I might need to wait for the payment to happen, which might take, I mean, in terms of wire transfer, it might be even days. In terms of credit card payments, I need to at least wait for the credit card service to be available. I might see the message, send a message and wait for the response. So there are a couple of things I need to wait. So it's stateful, it's long running. That's why it makes a lot of sense to do that with the workflow engine, like, for example, Camunda. And then this orchestration logic is part of the business logic of the order fulfillment microservice. Again, I'm not going into any kind of code or any kind of demo, But code for this example is available in GitHub. There's a link. You get the slides later on. So, and now you also have that one place where you can easily adjust the logic. You can understand it. You can look at it. You can even analyze a lot of data. So if you're looking at, for example, Camunda, you can go into optimize and understand like how long does it normally take, or where do we cancel orders, or whatever you want to know. You have that place where you can go, and you can adjust it. Like, for example, doing things in parallel, exchanging sequences, and so on and so forth. Cool. And then in a microservices world, different microservices might have their kind of local processes. Like payment might have one in order to charge the credit card, retry that. If that doesn't work, to clean up and whatever, right? Order fulfillment doesn't have any details about payment, but it simply says, hey, payment, retrieve the payment for me, and then it waits for it to happen before it moves on, right? So it's kind of a distributed thing. And that means all the orchestration logic, it's domain logic, it's local to one microservice. And this thought, it's very important if you want to do microservices, because you shouldn't do a centralized orchestration service in that sense. We have customers doing that also successfully, so I don't think it's a bad solution necessarily. But if you want to do microservices with a microservices mindset, this is definitely the way to go. Cool. Right. Glenn quickly said that in the beginning, but I finished the content, but we're currently in the process of releasing practical process automation. So it's in early release, available already. It should be there in real end of March, and in April you should even get it as print if you like. I worked a lot of these thoughts also into the book. So for example, orchestration versus choreography, there's a whole chapter on that. Or yeah. So if you're interested, check that out. There's a link also for 30 days trial on early release for Riley. So you can definitely have a look on that. On the web page for the book, I also linked all the examples I referred to. So that's probably the easiest to just go there and then take it from there. So as a quick summary, use a workflow engine whenever you have something long running, right? You get visibility on top, and that's very, very important for business agility to understand what you're doing. And that's a kind of the basis for changing things. If you do microservices, event-driven architecture is great for some use cases, but it's not the magic cure. You will use orchestration for some other parts of that equation that helps to avoid chaos. It can be decentral, so it's nothing which must be centralized, and it doesn't mean synchronous communication. Cool. That was it. I tried to make it as quick as possible to have enough time for questions. We haven't talked about that. Do we moderate the question, or do I simply pick questions?
The questions are voted at the top.
So we start from the top.
Well, that's if you want to go with what people want. If you also want to scroll down and take a look for a question that you like to look up, that's also fine. Just a reminder to everybody, if you want to vote questions that you'd like to hear the answer to, or you'd like to add your own, the link again is posted there. So yeah, you can go ahead and
let's see if I'm actually not sure if I'm. Yeah, I can. Okay, I can lock them. Did you do that, or did I?
I did that. Yeah. I was just
cool.
seeing if it
because
worked.
I think I can't do it on the slide. Yeah, let's do the first one first. So, are we dealing with customers making microservice architectures from scratch? No, I wouldn't say so. So, most companies don't have a green field nowadays. They don't have that luxury. So, they have an existing architecture and they move towards more microservices, let's say that way. And that's an evolution. It's normally not a, hey, we throw out the monolith, here's the shiny new thing. It normally is really, they carve out small parts of the monolith into small microservices. And it normally means, for example, now there are a couple of things I want to say to that. So the first is like what I call pain-driven development. So it normally happens because you have to do something in the system. You have to implement a certain change, which is not easy to do in the monolith. So instead of doing that in the monolith, what they do is they start developing one microservice, and put the functionality in there, very often with the process included they need for that. And that includes that you need to do two things. The first is like, you have to provide a facade, an API in the monolith to access certain functionality, which is very often very hard. And the second thing is they need to cut certain things which are going on under the hood in the monolith for certain functionalities. Okay, and if you succeed doing that, which is very often very hard for the first microservices you do, but if you do that, what you will gain is that the microservice, the monolith gets smaller. Normally, at least in process logic, it might keep the data still, but it reduces the amount of process logic, and you get more and more microservices. And the longer you do that, the better you get at that. And that's I find that the most successful strategy so far. Sometimes it also happens that you do these microservices for things you need to change often, or whatever the motivation might be. But there must be a true business case for that. I hope that answers the question.
I've ticked it answered, so I think yeah, that means that it has been decided, it has been answered. You can also, I just took a look, most of the questions have a vote of 3, so I guess you can pick any of the top 3 there. I can pick one for you. There's one I quite want the answer to, if you don't mind.
Go.
Sure. There it is, pop on the top.
So as everything in life, that's no, it depends answer. No, not necessarily, right? You can do it wrong, and then you will probably have a negative impact on your performance. I mean, the distributed system and the microservice architecture always have kind of a negative impact to performance normally. On the other hand, it might increase scalability of the system. So, and that might increase throughput, observed throughput from the outside. So it's hard to answer that question without defining what performance is. What I can answer is, I mean, if you look at how the workflow engine is built, for example, we're not adding a lot of overhead, and we have scenarios where we put a lot of load on the data on the workflow engine that behaves very, very well. So I would say no, not normally doesn't impact performance. Yeah.
Answered.
I should. Most of the time, I just recognize that pattern more and more often. I could simply answer yes. I probably should do that.
Well,
save so much time.
I do like the switch with the it depends sign. At least you use it once. So I hope it comes back more often.
I'm going to use another question here that came quite early on in your presentation, because you mentioned the statement that companies are becoming software, and I think
I mean the reason is basically the following. So if you are not handling physical goods, and let's make it the other way around, like insurances, banking, and telco, it's still let's say the industries we've grown up with. I mean, we are now really across all industries, but banking, insurance, and telco were kind of the biggest in the beginning. If you look at what they're doing, I mean, a bank transfers money, and that doesn't mean you put money in a suitcase and go somewhere. It basically means you put data somewhere saying, okay, somebody transferred money. It's all virtual. The same goes for an insurance. Yes, they send a contract out, you sign in reality, but basically they manage risk. It's all virtual. Like for telecommunication, it's the same thing. Most of what they do is all virtual. And that means in order to implement the business, what you really do is you write some kind of software, right? In order to make the money transfer, in order to get the contract right, in order to settle the claim. It's really all software. And that means in order to be successful with that, you have to be good at writing software. And this is why, for example, companies fear that death by Amazon, because what we all know is that Amazon is pretty good at writing software. And they, over time, they took over certain parts of other industries, which are totally not selling books. It's about providing a cloud service. It's about even selling insurance nowadays. because they're good at writing software. And in the future, we will see that more and more, that companies that are really good at writing software to automate certain business models will be more successful than others. That's kind of what I mean.
Super, thanks, Bernd. Can I pick another question for you? I don't often have the ability to make you answer questions I want to know the answers to. So this is actually one that was added just recently, but I think it stands to a few other questions that were asked as well. There's another question about embedded engine versus distributed, and I think it's a high-level question that's worth addressing.
Yeah, that's an interesting one. So, and that's really an it depends answer, like always. I keep that sign up. There it is, Suresh. So first of all, my default with the microservice architecture, because of the autonomy of the services, every microservice should have its own workflow engine, because then you're totally autonomous. You're not, another service can't mess with your data, it can't mess with your performance. You can upgrade the engine whenever you want without talking to anybody else. You can select the engine you want without, at least until you're talking to anybody else. So that's isolated from everybody else. That's great. That's kind of the default you're aiming at. Now, two things. Embedded engine, that's kind of what most customers currently do with Camunda BPM, because we have that great Spring Boot starter, and you just add it to your microservice if that's a Java Spring Boot microservice, and it's there. It's really easy to handle. That's why it's so so successful. And that's a good model. I like it, actually. There's a certain price you have to pay for that, and that means you have the workflow engine as part of every service, and that also means you probably have to configure it. At least if you do high performance, high throughput things, sometimes you want to tune it a little bit. There are a couple of things you might want to do with it. With recent developments in the direction of cloud, what gets more and more famous is that model of the engine as a service. I mean, that's also what we provide with Camunda Cloud, engine as a service, but I know also a lot of customers doing that in their own environment. And that means you externalize the engine, but I would still have one engine per microservice. It would still be my default. And then you have the problem, and that's, sorry, it's not, I'm still talking now, I'm sorry.
It's too fast, it's too fast.
No worries. And then you have that problem, what customers describe, that they now have these multiple engines and they want to gain back one view over all these workflow engines, like what's going on in the different workflow engines. And that's another problem where sometimes some customers do a solution where they say, okay, now we have that one engine, which basically basically all of them meet in one database, and then you can look at that. I'm not a biggest fan of that, but it works if you know what you're doing. But this is a problem we are also currently looking at, like supporting that better to basically get data from different engines and put that into like one joint view. We're doing a bit of things in Optimize at the moment. We're looking at a couple of other things. So yeah, working on that at the moment.
Cool. There are like two questions here that are voted 3 each. I'll let you pick one of them. I'll give you a choice.
Awesome. Then I have to read them first.
One is about track and trace. One is about persistence of data.
I just start at the top. If there's support for track and trace to correlate AL events being part of a request. I mean, yes, of course, but it's not related to Camunda. I mean, you can use the typical tracing tools to build traces. And for example, for Zipkin, there's a proof of concept we also did to keep the trace ID you get from a request if you use Spring Boot and Spring Boot Floyd in the process context to continue that when you continue on, so that this survives basically the long running part. There's still a debate if that's a good idea, because long running could be really long running, and these traces are normally like within seconds. But technically that's a possibility. But overall, you'd simply use tracing as you would do otherwise as well. So if you look at the Camunda BPM engine, what I had earlier on that one slide, it really means persistency is done via a relational database. So if you think of the Spring Boot starter, it means you use the data source, which is available in Spring Boot. And then you have a couple of tables, like, hey, there's one table where it stores the process instance with the current state. And if it moves on, it updates that state. It works in a transactional model as you know it from other Java applications. If you look at Camunda Cloud, which is kind of a different engine architecture, it works very differently. I'm not going into details of that here because that's probably not what you're using. And if you go for Camunda Cloud, you're not really exposed to much how it stores data. But basically what we did there is we worked on technology that scales beyond the limitation of a relational database. That said, at the moment, we can handle all use cases we have seen in big scenarios also on a relational database. So we get quite far with that.
Cool, thanks, Bernd. Let's click. Is it possible to use Process Engine without needing to implement?
Yes, of course. Yeah. I mean, yes, in all possible scenarios. I mean, you could do, we have use cases where Camunda is used to orchestrate RPA bots without any microservice, probably even without too much of code. That's possible. You can use human task management to have like task forms sending around. You can embed it in your monolith if you like to. So yes, definitely there are 100 of ways of using Camunda without doing microservices. Why I'm talking about microservices is simply because that's kind of the most pressing questions we get from our customers around architecture, because they should move towards a microservices architecture, and they are not sure how to bring these things together of a process spanning multiple microservices and these microservices. But yes, definitely.
Fantastic. And I want to last question, I guess, for you, unless you know the current status of my hawk. I'm going to give you the easier question, which is how is Camunda dealing with consuming the ever-changing versions of services? I guess it's a versioning question.
And I would make a guess that it's about versioning of the microservices. So these microservices have different versions, probably with a new API or changed API. And if that's the case, I mean, it depends on what the version changes are in these microservices. But normally, I mean, if it's a backwards compatible API, you don't have to do anything in the process. If it's not, you might have to adjust how that microservice is called. And depending on how you did that, which is in 95% of the cases programming, then you need to adjust your programming, yes. But it makes a couple of guesses.
Nice, thanks, Bernd. So I think we have time for maybe a 6-minute break before Shirish takes over with his talk.
Yeah, one more thing just to add on top of what Bernd said. Also, one of the reasons we have to look at the versioning is the patterns we use. Remember, so from the perspective of external task pattern that I will dive into, or whether you use the internal Java delegates to do the calls, it really depends on that backwards compatibility to emphasize on what you need to do to maintain that stability of versioning. But also maybe I don't know if we're going to touch the migrations part in the engine. I wasn't going to address that, but maybe that's good to also note on in this question.
Yeah, it's super easy to migrate. And actually, you're right. If you use external tasks, which Shirish will be demonstrating after this, it's so easy to version stuff because everything is versioned independently. It's really easy to change the versions of specific services, specific processes, and then also to migrate them. It's a really simple process. So I think Shirish should be demonstrating that in about 5 minutes. So yeah, let's hope it all works. We'll take a break now, I guess, for about until 1/4 the hour in whatever time zone you happen to be in. So it's about 5 minutes from now. See you all back here in about that time.